All right, ladies and gentlemen, welcome to our first activity for winter 2023. We're going to be looking at stick figures. It's a skill that we need to develop because we use it on every test. They're also known as line angle drawing. And I'll start with an example. Here's a molecule drawn out fully. It's got every bond showing. I should have had somebody start a timer because this one's going to take me quite some time to write out. And it's not even a complicated molecule. I'm going to estimate that took about 25 seconds. And this is called, you'll tell me what it's called. It's the form where every single valence electron is shown. So what do you call a drawing where every single valence electron is shown? There's a gentleman's name that is synonymous with valence electron. His name is Lewis, Gilbert, if you want to know his first name. But Lewis. So whenever you hear the name Lewis, there's only two things in your brain. Valence, electron. Okay. Now some of you are saying, oh, I didn't learn it that way. I learned dots. Guys, what were those dots? What were those dots? Valence electrons. And the lines too. The sticks were bonds and they were valence electrons. Okay. So that's the Lewis structure. Lewis. I can speed things up and condense it. Condensed. And somebody have a timer they can start on their phone? Usually I don't want you using your phones, but if you can get a timer and just give me a 3, 2, 1 start, and I will start when you, and as soon as you say start, you hit start. So, anybody got it?
I'll do it.
Okay, I'm waiting for your 3, 2, 1.
All right, 3, 2, 1.
Stop. What you got?
12.68 seconds.
All right. Now you're going to do exactly the same thing again. And you just give me the 3, 2, 1.
3, 2, 1.
Stop.
7.8 seconds.
All right. You ready? One last time.
Right.
No, I'm not ready. Sorry. Okay. You give me your 3, 2, 1.
Ready?
Yeah.
3, 2, 1.
Stop.
All right, that was 2.5 seconds.
Excellent. I hope you're motivated to learn stick figures now. Because this is not even a big molecule. Yeah. No, you don't have to copy this. But I'll tell you what to copy. Just copy. I'm just going to tidy this up a little bit. You know, I was trying to show off. But really, I didn't lose anything. I'm just making it a little neater here. Not much. It's the same. I'm just trying to get it done as fast as I can to show off. Okay? But you got the point, right? These are all the same molecule, people. And until the day you can see that, you're not ready to excel at stick figures. So we got to figure out how this means this, this, and this. Okay. So right now, I need this. And we're going to go back to Mr. Lewis here. And I'll put some numbers on here. 1, 2, 3, 4. 1, 2, 3. Wait. I don't have the right molecule. I got myself. It should have been less than 2.5 seconds. I drew an extra carbon. All right. So I caught myself, but they're not impressed anymore at all. No, lost them. I'm not going to make you retime it. That's it. That took maybe less time. I can put an extra carbon. Okay, I caught myself when I did the numbering. 1, 2, 3, 4. Okay, they're both molecules that have 4 carbons in the longest chain. Get used to those 2 words. When I say longest chain, which I will a lot, that means the longest continuous chain of carbons you can count. So nobody can get more than 4, no matter where they start in this thing. If you start here, you're going to get to 4. If you start here, you're going to get to 4. You start here, you're going to get to 4. You start here, you can't even get to 4. You start in the middle, you can't ever get to 4. So it's an important skill to find the longest chain. And they have 4 in a row. So talk to me about carbon 1. What part of carbon 1 down here do you see that also exists up here? 1, I don't see the carbon itself. So I have to know what the stick figure short form for a carbon is. And give me the 2 short forms for carbon. End of a stick is a carbon. End of a stick is a carbon unless otherwise stated. We'll do an otherwise stated a little later. So that's one place you'll find a carbon. I'm going to put a green dot on everything that matches that description. Got it? Those are 5 carbons in this molecule. Now, intersection of sticks. Is a carbon, unless otherwise stated. Better do an otherwise stated very soon. Hello? And that would be this intersection and this intersection. See those 2 red dots? Okay, so I already know there's 8. Is that right? 8? 1, 2, 3, 4, 5, 6, 7 carbons in this molecule. Yeah. Okay, so I know that. We need a nice table. Nice table. What's the easiest way to do a table? Well, in this table, I want to know element. I want to know how many bonds that element likes to make, number of bonds. And I want to know number of lone pairs that molecule likes to make. And the table. Okay, we can do better than that. Table needs straight lines. And we're going to do more than that. I don't think the lines need to be that long. Wow. Okay. Wow. Sorry. What is the most important element in this course? Carbon. Why do you say that? That's a great answer, by the way. Why do you say that? They said carbon. They were correct. We're going to put it, I don't know, third. Because we love the periodic table and we love organizing our thoughts based on the periodic table. What is the second most important element in this course? Hydrogen. Do you know why? Because every organic molecule has carbon bonded to hydrogen at least once. If it doesn't have carbon bonded to hydrogen at least once, it's not an organic molecule. Okay. So, we deal a lot with boron in this course. Although it's not very popular as like a natural molecule in organic chemistry, boron is used a lot synthetically in the lab. So boron, and what's the one right after carbon on the periodic table? Because that's how I'm organizing this. Sorry? Nitrogen? And then oxygen? And then fluorine. I'm going to put fluorine. Yes, sure. I'm going to leave that. Sorry. Need a bottom to my table. Need some vertical lines. How many bonds does hydrogen like to make? One. And when it has that one bond, does it have lone pairs? Better not. First row elements have room only for 2 electrons around the nucleus, right? Why don't you go straight to carbon now? Most important, right? You got to know how many bonds carbon makes every time. What is it? 4. How many lone pairs does carbon like to have? It does not like having lone pairs. Don't go to boron. Go to nitrogen next, because you know nitrogen. Guys, are you thinking about ammonia? NH3? Isn't that a nice molecule that has nitrogen with all the bonds it needs and all the lone pairs? And it's really small, so it's easy. How many bonds are there in NH3? 3. So that gives nitrogen 6 electrons around its nucleus, right? Where are the other 2 electrons? Lone pairs. 1 lone pair is 2 more electrons, total 8. What about oxygen? Think about water. How many H's are on water? Because that's your bond. 2. How many lone pairs to get an octet? 2. See why I'm doing it this way? Because there's a pattern now. How many bonds does fluorine like to make? 1. How many lone pairs does fluorine like to have? 3. And of course, a nice reminder that other elements, this is the beauty of Mr. Mendeleev. Oh, we didn't finish boron, huh? Boron, beware, ALF, gags in toilet. What? And one day in my life, they made us memorize the periodic table and we came up with a lot of cute little memory devices. Where did I get those elements from? It's not random elements, people. Yeah, you'd be looking over there. Yeah, the whole column has this pattern. Hey, boron's weird. What's the Roman numeral above boron there? Only the people way over there can see it. It's in yellow. 3. That means it makes 3 bonds. Yeah. Here. I can sneak in group. Group here. Group. Barely can see it there. 1, 2, 3, 4, 5, 6, and 7. Okay. So boron likes 3. And how many lone pairs? Nah, zero. Think about it, BH3. It's right here. We got I for that and I for that. So that's 3 plus 1 times 3 equals 6. You only have 6 electrons available, right? You can't put 2 electrons on there. You can't put a lone pair on there. You don't have it. You don't have that number of electrons. These Roman numerals tell us the number of valence electrons. That's what group is, right? Group is VE. VE. What's VE stand for? Valence electrons, whose name is synonymous with valence electrons. Lewis. Okay. So carbon, silicon, germanium, tin, lead. Phosphorus, arsenic, antimony, and bismuth. You don't want to know the device I used to memorize that. I'll just say the end. Son of a bismuth. There you go. Okay. Sulfur, selenium, tellurium, polonium. I didn't have one for that. And fluorine, chlorine, bromine, iodine. We don't get to the astatine in this course too much, but there you go. It's essential you know this table. You don't do Lewis structures unless you know this table. Don't even start doing Lewis structures unless you know this table, like it's embedded in your head. Okay? So, we're going back to stick figures, finally. This carbon is bonded to carbon 2. Do you agree? 1 and 2. 1 and 2. That's 1 bond to carbon 1. Do you agree? How many bonds does carbon like to make? 4. How many bonds, therefore, are missing? 3. What is the only element that is missing here that we have to figure out? What element? Hydrogen. You are only allowed to omit H's that are on carbon. Okay. So, I know a lot of you are copying everything down. You're being good students. I really didn't need you to do that, but that's good. It's a good start for the day. So I think for activity 1, I don't want to steal your paper. Although you're going to get this posted. So I am going to steal your paper. I changed my mind just now. Okay. So you're going to put, this is good activity 1 stop, and we'll get another video going for activity 2. And for our first activity, whatever you have written down is fine. Okay? Stop writing. Don't copy anymore. It's fine. I got your name on it. For first activity, we're just getting into a routine. First activity, I just need your name and whatever you've scribbled down. And we're stopping.